Hello, today we're going to look at project defaults and how we might use them to make our lives easier in ClearCalcs, work faster, and make less mistakes. So we're going to go through a bit of an example here. We're going to look at floor joist and how we might use project defaults to change these. So I'm going to start here. Since we're going to be looking at floor joists, I'm going to start by setting my deflection limit. So if I come here to my deflection span limits, I can look at floors. And I see by default, I've got a L over 360 short-term deflection limit and a L over 240 long-term deflection limit. We see KD plus L, so that means the creep component of our dead load. So only the creep component, so after the beam is installed, and the live load. So we're limited to L over 240. And we've also got kind of our simple dead load plus live load, total load check, and we've got an L over 180 right now. So we're going to assume here that we're working for a upper scale customer and they want more comfortable floors. So they might decide, say, to bump this up to, say, let's say L over 600 for deflection, L over, say, 360 for the creep. And they might also just say L over 360 for the dead plus live. So let's put that here like this. And taking a step back here. So now we've set our deflection limits. And since we're talking about floor loads, we're going to ignore the roof loads. We're going to ignore the ceiling loads. And we're going to ignore the wall loads. We're only going to focus on the default floor loads. So right now, by default, we've got this is residential 1 and 2 family dwellings. And we can see the 40 pounds per square foot live load. Now, let's open this. And let's say that we are actually designing a reading room for a library. So we can see now we've got a 60 pounds per square foot live load and a 1,000-pound alternative minimum live load. So the alternative minimum live load, what that means is that we're not going to apply it at the same time as the 60 PSF. What we're saying here is maybe someone's stacking a bunch of books on the wrong joist, and we just want to make sure that the specific joist can hold up that 1,000-pound load. But typically what's going to be governing for, say, deflection or something like that is going to be our live load in PSF. So this is typically a code requirement, especially when we're dealing with commercial or institutional buildings. So what I'm going to do now is I'm going to create our first joist. I'm going to come here, wood beam ASD, floor joist. Okay, so I'm in my floor joist calculator now, and I can already see that things are not passing. That's fine. And if I scroll down, I'll immediately see I've got my alternative minimum live load of 1,000 pounds here. And I can also see I've got my 60 pounds per square foot live load. So I know the right loads are being applied to my joist. And if I click here, I can see if I go to my live load, it comes directly from my project defaults, WL, meaning it's my live load. And you can see 60 pounds per square foot. Same with the dead load, 10 PSF floor dead load. And it's the same thing if I come here, my alternative minimum live load. So we're good here. So let's say our plan length here for our beam is 14 feet, all good. Let's come here and see what we can use. We're going to look at, say, I-joists today. And we're going to look at BCI joists. So if I scroll down, I can see I've got my tight deflection here, my delta symbol. You can see that's usually what's governing, but I could use a 11 7/8 60S beam here, or I could potentially go with a 14-inch 5000S joist. In this case, we'll go with the 14-inch, and we'll pick this. So we're just going to let this load, and now I can see everything is passing, so I'm happy. And I know that it's resisting the right loads because I've entered these from the project default. And I can also look at my deflection limit. My short-term deflection limit's at L over 600. We're at L over 608, so we're happy. Things are good. Now let's create another joist, and this one we're going to have the same loads, but we're going to have a different span length, just to see what we can do with this. So I said we're going to have the same load, but a different plan length. I'm going to set this to only 8 feet in this case. And if I scroll down here, I've already got my 1,000-pound minimum live load, as well as my 60 PSF live load. So we're happy. Everything's good. And I do want to keep using iJoist, so I'm going to come here now and select iJoists. And I said I was using the BCI joists. So if I look here, I can go with actually the smallest iJoist in our catalog. And that gets us exactly right at 100% utilization, so we know it's extremely efficient. Again, we look at our short-term deflection, we're at L over 601. So life's good. Everything is perfect here. So everything is good. It's designed. We've sent it. It's ready for construction. And ouch, we've got a client who comes back and decides they don't want to use it as a library anymore. They want to use it as something else. So no problem. We say we go to our default floor loads and we say, what kind of live load you got? And they say, actually, I want to build an ice skating rink. Okay, no problem, right? And so we look and ouch, our live load just switched from 60 pounds per square foot to 250 pounds per square foot. That's going to have an impact on our joist, right? And so if we look here, our projects, our calculations now, they're automatically recalculating. And if I look, ooh, we're failing in both. One of them is at 276% utilization. The other one's at 157%. So we know there's a problem. Now, because we know that these are so high, one thing we might think is, okay, perhaps we want to change our joist spacing so that they're closer and we can take this load better. So if I come here, my default member spacings, I've got 16 inches. I can now decide to change that to 12 inches. Now let's see what impact this has. We're going to look at this. We can actually go to our member schedule as well and let these calculations run. So in our member schedule, we're looking here and we see 118% short-term deflection, 207% short-term deflection again. So I can actually, now that I'm in my member schedule, I can just go here and edit this. And now that I'm here, I can go look. I've got my BCI joist. So if I scroll down, oh, we get pretty close, but if with a 16-inch 90S, we do almost pass with, except for a reaction that's, we'll call it close enough in this case. So we set this 103%, and we're going to do the same thing with our second joist. That's the 8-foot span. Okay, and now I can look down and see, okay, I was using the 4500S. If I jump to the 9600S, everything is okay. And with that, now I might say, you know what, I'm not actually comfortable with the 103%. I'd like to change my my bearing length just so I can sleep better at night. So I go back to my project defaults and I see my default bearing length right now is 3 inches. Maybe, you know what, I won't take any chances. I'll bump this to 5 inches. So maybe it's bearing on a 2x6 top plate. And I can now go here back to my member schedule. We'll let the calculations perform again. And now we see, okay, we're at 98% and 97%. So everything is good. If we hover over here, we'll see 98%, and it also shows us our member. So with that, I'll stop the video here, but thank you for listening. And as always, you can reach out to us anytime for help. You can just click on the help button here. You'll see our email. It might open up the answers here, so you'll see some answers, or you can also choose to email us right here, and we're more than happy to help anytime. Thank you very much.